Hello, welcome back to the Python lecture. In the previous lecture, we were talking about the non-primitive data type, and we picked up list as our first non-primitive data type. We have seen how we can declare the list and what are the indexing present inside the list. Okay, so as you guys have seen that we have covered till indexing, we have also seen the last, or let's say the first method related to the list, which is dot append, that helps us to add element by the end of the list. Okay, if you guys remember, I have given you one homework that try to extract guava from the nest list. You can see that this is your nest list. Okay, and if you want to extract guava from this list, how you're going to do that? So as you can see, this is your list. If you want, you can also count the index position from the forward direction, but I can see it is most suitable to count the index position from the backward direction. So what I'm doing, I'm just putting this one as -1. This whole list is going to be -2 for me. Okay, so my first index which I'm going to write here is -2. Now we have to extract guava. Okay, so we have to again do indexing within this list. So how we are going to do indexing here? This is going to be again -1, and this is going to be your -2. So you can either write -2, that is one way. You can see guava is getting extracted. If you want to move with the forward direction, you can also write 0, 1, 2, 3, 4, 5. So to reach to this list, you have to write nest of list 5. And then after reaching to this list, you know that we have to reach to this guava as well. So we have to mention the index position of guava, which is going to be 3. So, oh my bad, it is going to be 2. Because as you guys know, index position starts from 0, right? So this is going to be a 0, 1 and 2. So index position 5 along with index position 2 will help me to extract guava. So this is the answer of your homework which I have given to you previously. Now coming back to the point, let's continue with the rest of the methods present for the list. Okay, previously we have seen that if we want to append one element by the end of the list, right? So it is very specific that you can only add one element by the end of the list. Okay, not in any other places, it is going to be the end only. Okay, coming back to the point, let's pick up the another method where I want to add multiple elements by the end of the list. Okay, now I'm talking about multiple elements. Previously that append was helping you to add one element at a time. Now I want to add multiple elements at a time by the end of the list. How we are going to do that? Simply you have to mention the name of the list. As you can see, we have the list present here as list underscore 1. Let me show you how this is actually looking like, because previously we have already appended one element. So this is going to be our final list. Now I want to add multiple elements. For that we are using dot extend method. Okay, now what is dot extend? Dot extend helps us to add multiple elements by the end of the list. Now there is one thing that within dot extend you have to mention one list. Okay, and you can see I am declaring one square bracket. What is the reason behind that? Because you know that multiple elements are going to get added within the predefined or already defined list. So we cannot declare elements like separately. Okay, it is not possible. Whenever there are multiple elements coming into the picture, we have to bind them up into one container. So here in our case, we are picking list as our container, which is going to get used inside the dot extend method. Suppose I want to add, let's say, banana and lychee. Okay, I am simply writing dot extend and running it. Now what I told you, whatever changes you guys are going to make with the help of methods, those are permanent inside your list, which means if you are going to print list underscore 1 right now, it is going to give you the updated list. Now you can see banana and lychee, they both are getting added here in this list. Okay, now suppose if you want to add element at some respective position inside the list. Okay, you know some respective index position and you want to add that element in that particular index position. What you are going to do? In that case, simply you have to write list underscore 1 dot insert, and inside insert, let's say you have to mention the index position where you want to add the element. Let's say I want to add the element between string and true. Okay, what is going to be the index position for that? This is index position 0, this is 1, this is 2. In the middle it is going to be 3. Okay, so I'm simply writing 3 as my index position. Now I want to add the element. I'm going to mention the name of the element. Let's say new is the name of my element. So at index position 3, I am adding one new element here. Okay, you can give the name of the element anything which you want. As of now, I'm giving this as new. So the element which you guys are adding, it is not necessary that it should be string, right? It could be any data type. You can select any data type of your own choice. Okay, so understand one thing, that we have covered the manipulation of list, which means manipulation in the sense whenever I want to add the values in the predefined list. Okay, single value with the help of append, multiple values with the help of extend, and value at some desired index position with the help of insert. Okay, now since we have covered all these things, let's jump into the deletion part. We have seen how we can insert the values inside the list. Now the question arises how we can delete the values from the list, right? So for the deletion purpose, if I show you in the help section, we do have multiple methods for doing the deletion inside the list. The pop is going to help us out, remove is going to help us out. Okay, now suppose you only know, if you want to delete element from the last of the list. What does that mean? By the end of the list, you want to pick up the last element and you want to delete that element. In that case, what you're going to do? In that case, you can simply do one thing. Mention the name of the list from which you want to perform deletion and write dot pop method. Here in this dot pop, you don't need to mention anything, because by default if you're going to write simple dot pop, it will pop up the last element out of your list, which means what is the last element of my list underscore 1? That is lychee. It is going to pop up that element out of the list. You can see now lychee is no more there in the list underscore 1. If you want, you can check this by simply writing your print list underscore 1. Okay, so we are deleting the element from the last of the list, and you guys also see one thing, that it is only deleting one element at a time. So this is again one property where you can only delete one element at a time. Okay, now moving forward, suppose you want to delete something from the desired index position. Okay, you know the index position and you want to delete the element from that index position. So in that case, what you're going to do? So for that purpose, you have to mention, what you have to mention? The index position along with pop. So let's say if I'm having list underscore 1, I'm simply writing dot pop. Inside that, I'm going to mention the index position of the element which I want to delete. Let's say this is 0, 1, 2. Let's say I want to delete string. I'm going to mention 2 as my index position. Running this, you can see it is deleting string for me. Again, if you want, you can check by simply writing print here with the list. You can see no longer exist. Okay, now there is one more method for performing deletion from the list. That method is nothing but remove. So when we want to delete the element from the list. Here you guys don't know what is the index position, what are the things, okay? We don't know all of these things. We just know the element and we want to delete that element. How this is possible? You can simply mention list underscore 1 as the name of your list. Write dot remove. Inside dot remove, you have to mention the element which you want to delete. So I want to delete apple. I am mentioning apple, and this is how it is going to delete the apple from the list. Running it. If you want to check, you can check your list underscore 1. We have the final list after performing all the deletion from it. Okay. If you look into the list, previously what we have done, first we have added the elements inside the list. Now we removed the elements from the list. Okay, so basically what are we doing? We are doing the manipulation of the list. So whenever you are having predefined list and you want to perform manipulation in that, you want to add something, you want to remove something, you are going to do that with the help of built-in methods. Okay, so this is how your built-in methods work. Now once the manipulation is done, we will see what all methods are left. Okay, you can see we do have clear, we have count, we have index, and we have sort and reverse. So these all four methods have some different functionalities. Okay, completely different from the things which we have learned up till now. So suppose if you want to identify the index position of some element present inside the list. Suppose you are having the list and you want to identify the index position of some element. Let's say you want to identify the index position of new from list 1. What are you going to do? Simply write list underscore 1 dot index and mention the name of element. Okay, if you are going to do that, it is going to give you the index position. Always understand one thing, that index position given by this list is completely forward directional. It is not going to give you the backward directional answer. Okay, only one way answer is going to get given, and that is nothing but the forward indexing. Okay, now clear. There is one thing called as clear. We want to delete all the elements from the list but keep the identity of the list intact. Means what? I want to clear the list, which means there should be no elements present inside the list, but list should be there. For example, let's jump into the whiteboard to understand this thing. Suppose you are having one list like this. Inside the list you are having elements 2, 3, 4, 6, 8, like this. Now if I am going to apply dot clear in this list, what is going to happen? This dot clear is going to remove these elements from the list, but my list is going to be there available, which means my list is one is going to be there, but the nature of that list is going to be the emptied one, or you can say that it is nothing but one empty list. Okay, so that is what dot clear helps us to do. Dot clear helps us to remove the elements present inside the list, and but helps us to keep the identity of the list intact. So suppose if I want to empty the list, I'm going to simply write list underscore 1 dot clear. This is going to empty my list. If I'm going to print the list once again, you will see this is nothing but one empty list available. Okay, now there is one more way or one thing to create a copy of a list. Suppose we are having this list of large. right? I'm printing the list of large. Previously we have already declared. I'm printing list of large, how it is looking like. Okay, to run this cell. Yeah, so since this error occurred, let me tell you one thing. Whenever you open Jupyter Notebook, there is a thing that you have to run all the cells of the Jupyter Notebook again. Okay, which means, let's say if you are opening the Jupyter Notebook today and you are working in it, no problem, no issues are going to be there. But let's say suppose you are coming tomorrow and you want to write some program within the same Jupyter Notebook. You have to run every cell present inside that Jupyter Notebook. Then only it is going to read the variables which you have declared previously. So this is the basic trick. Always remember, whenever you open your Jupyter Notebook, run all the cells. Then only your previous variables are going to be there, which you guys can read it. Okay, unless it is going to show name error, which means that you haven't declared the variable yet, but still you are calling it or using it. Okay, so just remember this thing every time you work with Jupyter. Coming back to the point, list of large, right? Now in this list of large, I want to create a copy of all the elements present inside the list of large. Okay, writing it down. Create a copy of all the elements present inside list of large. How we can create a copy? So for creating a copy, we have dot copy method. Okay, I'm simply writing list of large dot copy. Now where this copy is going to get stored? Coming here, I'm storing that in the variable copied list. Running this cell. Now if you print the copied list, you will see all the elements of list of large present inside the copied list. You can see. Now the question arises, are they getting stored within the same memory location? The answer is no. They are getting stored in the separate memory location. Now list of large is a separate variable which you can use, and list of, or let's say copied list, is another separate variable which you can use independently. Okay. Now, there are two methods left called as sort and reverse. After completing those two methods, your list will be done. Okay. So, let's understand what is sort and what is reverse. Okay. Give me a minute. Let me clear the board. Okay. So, we are going to talk about dot sort and dot reverse. First, understand what is sorting and what is reversing. Okay, when I'm saying that we are having a list like this, okay, this is your list, and now you want to, let me declare one few more elements, let's say 12, 21. Okay, so suppose if you decide to sort that list, okay, with the help of dot sort method. What is sorting? Sorting works in two format: ascending, another one is descending. When I say that I am sorting something in the ascending order, which means we are sorting in this direction, which means from smaller terms to the larger term. When I'm saying I am sorting something in the descending order, which means from larger term to the shorter term. Okay, so we have two sortings. Suppose if I'm going to perform the sort in the ascending order of the list underscore 1, how this is going to get sorted? Simply your final list is going to look like this. Ascending means what? Smaller elements will come first. 0, 1, 2, 3, 12, 21, 100, 200. Okay, so these all are your elements which gets sorted in the ascending format. Similarly, if I want to sort this list in the descending order, the final list is going to look like 200, 100, 21, 12, 3, 2, 1 and 0. Okay, so this is how your ascending and descending works. Now let's hop into the Jupyter notebook and let's do this ascending and descending thing. Always understand that your ascending and descending thing works with numerical type of data and string type of data. In numerical, according to the numbers it is going to sort. In string, it is going to sort according to the alphabetical order. It is going to sort according to the alphabetical letters. Okay, now here alphabetical letters are going to come into the picture. According to the order of alphabets, it is going to sort those values. Okay, so either you have to create list of all numbers or you have to create list of all strings. Then only sorting is possible. So let me declare list of all numbers so that we can perform sorting. Let me write it down. List of number equals to 0, 23, 14, 25. Okay, now this is list of your number. Suppose you want to perform this sorting in the ascending order. What you have to do is simply write list of number dot sort here and run it. Now if you check your list of numbers, you will see it is sorting by default in the ascending order. So whenever you want to sort something in the ascending order, you don't need to mention it. Okay, you just directly write dot sort and by default it is going to sort in the ascending order. Now same thing, I am taking the example of list of strings where I want to sort them in the descending order. Okay, I am writing basketball, apple, banana, cat, like this. Now I want to sort them in the descending order, which means from the higher order alphabet to the lower order alphabet. So in that case, I'm going to simply write list of string dot sort. Inside you have to mention reverse is equals to true. Please be cautious that your true is nothing but your boolean data type. That will help you to reverse the order of the alphabets present inside the list. Okay, now if you are going to run this and check list of string, you will see it is going to sort them in the alphabetical order but in the descending format. You can do the same thing with the list of numbers. Let's say this is list of number and you want to sort them in the descending order. You can simply write list of number dot sort, reverse is equals to true, and then it is going to get sorted in the descending order. Very simple. Okay, now we will be talking about the reverse, which is the very last method of the list. Let me clear the whiteboard and let me again declare the list. Now here there is no restrictions or limitation that you have to declare the list let's say in the ascending order or in the descending order, or let's say you have to declare the list of numbers only, then only it is going to work, list of strings only, then it is going to work. No, here you can keep up the combination for performing the reverse of a list. Okay, so I am writing list of, let's say, x. This is my list. It is containing the combination of numbers along with the alphabets. Let's say 1, 2, XYZ, 44, 85, apple. This is your list. Okay. Now you want to reverse this list with the help of dot reverse method. How the reversing is going to happen? Reversing means I am using the reverse method, which means the elements which are getting listed down in this direction, now it is going to get listed down in this direction. Once I apply reverse to this list of x, your final list of x is going to look somewhat like this. First apple is going to come into the picture. 85, 44, xyz, 2 and 1. So what it is simply reversing the order of the values present inside the list. Okay, nothing more. Okay, so what you have to do, simply write dot reverse and it is going to help you to reverse the list. Going back to the Jupyter notebook, pick up this list of string. As you can see how my list of string is looking like right now. This is our list of string, final. Okay, after performing the sort, you know, whenever we sort something, the changes appears to be the final. Now coming back to the point, whenever I want to, let's say I'm going to reverse this, which means apple is going to come in the first place. So I'm writing list of string dot reverse. Okay, now if I check list of string, you will see it is nothing but a reversed list. Okay, always remember whatever changes we are doing with the help of methods are the permanent changes. Okay, permanent changes which it is going to make the modification in the list permanently, which means even if you try to make or change the list, let's say even if you try to take back the list to its original state, it is not possible, because once the list is changed with the help of methods, we cannot take that back to its original format. Okay. Yeah, moving forward, now this data type is covered, which means this list data type is covered. We'll be moving forward with another data type called as tuple. Okay, let me give you the heading. What is tuple? We will understand that. Okay, and how list is different from tuple, why there is a need of the declaration of tuple. We will understand all of these things. Okay, so since I'm saying something is in the tuple format, okay, again do not forget that it is non-primitive data type, which means again it is non-homogeneous in nature, contains the collection of different type of values. Okay, now previously if you guys remember, we declared list with the square bracket. We are going to declare tuple, we are going to declare tuple here in the parenthesis format. Okay, so you have to declare parenthesis before declaring the tuple. For example, let's say I am having tuple underscore x as my variable. I want to declare one tuple, so I'm using parenthesis. These brackets are called as parenthesis. Okay, tuple underscore x with the parenthesis like this. Now I'm declaring the values inside the tuple. As of now, I'm just declaring the floating point values and the numbers, or let's say integers. Okay, we will see later what all data types are supported inside the tuple. Now I'm just printing the value tuple underscore x, and this is how your tuple going to look like. Okay, tuple follows the same property as that of the list. There is few differences between the list and tuple, few major differences. First major difference is that the change in the brackets. Okay, what is the next major difference? I'll let you know. But before, if you want to check the data type of tuple underscore x, you can simply write type inside that tuple underscore x. Now once you understand how you declare tuple, let's say what all data types are supported inside the tuple. Okay, so let's say for example, I am telling you that we can declare any data type inside the tuple, same as that of your list. If you guys remember, list, what it says, that you can declare any data type, any primitive, any non-primitive data type. You can even declare list inside the list, right? Same here happens with the tuple. You can declare tuple. You can also declare tuple inside the tuple, and any other data type is possible to be declared inside the tuple. Okay, so we don't have any sort of restriction for that case. Okay, coming back to the point, let me declare the values inside the tuple. Let's say this is integer. We can also declare string type of value. We can also declare float type of value. Bool is also allowed. None type of data is also allowed. List is also allowed, and tuple within tuple is also allowed, which means nested tuple concept is real here. We can declare the tuples inside the tuples. Okay, now moving forward, when we can declare tuples inside the tuple, before going in that direction, before declaring the nested tuple, let's copy this and look into the same thing into the visual tutor, how this actually looks like. Okay, if you guys remember the previous thing, we have previous data type we have also seen inside the visual tutor, right? So I'm visualizing the execution. You can see that the numbers are still getting appeared here, which means you can draw the conclusion that same as that of your list, tuple also follows indexing. Okay, which means tuples also follows indexing. You can see 0, 1, 2, 3, 4, 5. Since it is following indexing, it also follows forward indexing, backward indexing, which means we can also extract the data out from the tuple with the help of indexing method. Okay, going back to the Jupyter notebook. Suppose if I ask you to extract apple out of this tuple, you're going to count the index position, right? This is 0, 1, 2. So you can perform indexing here. Tuple of data, second index position, extracting apple for me. Okay, so let's write few of the lines related to the tuple. Tuple is a type of non-primitive data type and follows almost same properties to as that of list, but also contains some major differences. Okay, so it follows some major differences as well, that we will see later. That is very important interview question as well. What is the actual difference between list and tuple? We will see that in the next lecture. Okay, as of now you guys have seen this thing. Let's say we can also declare all types of data inside the tuple, and we can declare all types of data inside the tuple, and it also follows indexing. Okay, now in the from the next lecture we will be watching, there is one terminology related to the indexing which we call it as slicing. Okay, so which of the data types supports indexing, they also support slicing, that we will see in next lecture. Also we will see what all are the methods related to the tuple, also what is the actual difference between the list and the tuple. Okay, as of now keeping the lecture this much only. From the next lecture, we'll be continuing with the basics of the tuple. Sorry, basics of the tuple is already completed. We will be continuing with the properties and the methods of the tuple. So that is it for today. Thanks for joining.